Okay, next example, we have another three-term one. So again, when you see multiple trig functions, it's probably a pretty good sign that you're going to have to factor it, just like if this was an x squared and an x again. This time we have three terms, so we will factor it like we would a normal trinomial, but we're just going to do it with signs. So again, a trick that might help as you're getting used to these, you can write this as x squared minus x minus 2, where I'm just doing x's instead of signs, and think of factoring it this way, and it's going to work the same here. So just like we would factor trinomials like this, we would think what multiplies to be that last number and adds to be that middle number. I like to do the little x table. So what multiplies to be -2 but adds to be -1. And so that would be -2 and 1, right? Because -2 times 1 is -2, but -2 plus 1 is -1. And before you would take, if this was just with x's, we would plug in x minus 2 and x plus 1, right? To factor it. We're going to do the same thing, except we're going to do it with signs over here. So we're doing the same numbers. So this is like there's a 1 in the front and a -2. We're just going to factor with signs. So I'm going to do sine x minus 2 and sine of x plus 1 equals 0. So that factors, again, the exact same way as a regular equation that you guys would be used to seeing with x's. So if that helps to write it like this first, you're more than welcome to do that. And then once you get to here, we're going to solve by taking each parenthesis and setting it equal to 0 and solving individually. So if I have this one, I want to add the 2 over. So sine x will equal 2 if I add that. And then on this one, we're going to minus the 1 over. So sine of x equals -1. And then we want to look at our unit circle. So on this one, we do have a number 2, which we're looking at our signs, we never equal 2 here, right? That's actually a domain error. Sine has to be between -1 and 1. So remember when we do our graph, we have that little sine wave going back and forth where it's top and it's bottom. If we're looking at just a regular sine of x, the lowest it can go is -1 and the highest it can go is +1. So we're saying when does it hit 2, which is outside of its domain. It can only bounce between -1 and 1. So on this one, it can't ever equal 2. So this one would have no solution. It would be a domain error. And if you put that into your calculator, you'd also get that domain error on it. But on this one, sine of x can equal -1. That's one of our parts in our unit circle. So again, we're looking at the second number is sine. So if we look, it equals -1 down here at the bottom. So if we take the radian for that, that would be 3 pi halves, or the degree would be 270. But let's take the radian. So we're saying x is going to equal 3 pi over 2. And so you only have one solution on that one, since this part didn't give any solutions and this only had one. So again, you can have lots of answers. You can have no answers, 1, 2, 3, 4. I think I've even seen up to like 6 or 8 before. So they each are a little bit different like that. Okay, and then last part are reciprocal trig functions. So we have worked a lot with sine, cosine, and tangent. The reciprocals, you probably learned a little bit about them last year. We haven't done too much with them this year, but these are going to be your cosecant, your secant, and your cotangent. So remember, reciprocal is if I take a fraction and flip it upside down. That's the definition of a reciprocal. So these are going to be reciprocals of our regular functions. So we have sine, cosine, tangent. Think of those as our regular normal trig functions. These three are going to be the reciprocals of those. So cosecant goes with sine and secant goes with cosine. I always kind of thought that seemed backwards. If I just looked at them, I would think sine goes with secant and cosecant goes with cosine, but it doesn't. It's backwards. So sine and cosecant are reciprocals of each other. So that means we can write them this way as well. So we can have 1 over cosecant is the same as sine, or do the flip of that, 1 over sine is the same as cosecant. So another way you can think of that is if I put these over a 1, think of those fractions flipping. So on this one, cosine will be the same as 1 over secant. Secant equals 1 over cosine. And then this one makes sense. Tangent and cotangent go together. So tangent is the same as 1 over cotangent, and then cotangent is the same as 1 over tangent. So this also applies to your SOHCAHTOA values. So remember, sine equals opposite over hypotenuse. So if I wanted to do the SOHCAHTOA, or the idea of those reciprocal functions was cosecant, I would just take this fraction and flip it upside down. So cosecant will be the same as h over o, or hypotenuse over opposite. And then secant will be the reciprocal of cosine, so I'll get h over a instead of a over h. And cotangent will be a over o instead of o over a. So you can even use these with your right triangle trig by just flipping those SOHCAHTOA fractions that we're used to upside down. So you'll see some problems like this as well, where they throw in these reciprocal functions. So here we see we have a secant. So remember, secant is the reciprocal of cosine. So they're saying what value of x, so what would I plug in for x right here that makes this a true statement? So what I do is I just flip it back to whatever its reciprocal function is, because on our unit circle, we don't have secant. We only have cosine, sine, and then we can get tangent. Remember, tangent is the sine value divided by the cosine value. I wrote it in purple again around my unit circle, which might be a smart thing to do. But because we don't have a secant on our unit circle, I like to flip it back to whatever one we do have. So secant matches with cosine. But in order to get the cosine, we need to flip and get the reciprocal of that fraction. So we're going to have a negative. The square root of 3 is going to now go to the top, and the 2 goes to the bottom. And you can think of the negative as being on the bottom or the top. It doesn't really matter. But now you can say, well, when does cosine equal negative square root of 3 over 2, which we do have on our unit circle. So then I look and I see, remember, cosine's the first number, and cosine equals a negative square root of 3 over 2 here at 5 pi over 6, or 150 degrees. And then it also equals negative square root of 3 over 2 down here at 7 pi over 6, or 210 degrees. So those would be your answers. So again, you could do radians or degrees depending on what they tell you to do. So we'd either have 5 pi over 6 and 7 pi over 6, or you could do the degrees and do 150 degrees and 210 degrees. So most of the time I feel like they use radians, but sometimes they'll ask for degrees. So again, whenever you see these ones, so secant, cosecant, cotangent, flip them into their normal trig function. So flip it to the sine, cosine, or tangent. And that, again, if we look up here, cosecant matches with sine, secant goes with cosine, and cotangent goes with tangent. So, and that is it for today. So let me know if you guys have any questions. Shoot me an email. But your homework is on Math Excel, so you can go ahead and get started with that, and it will look very similar to all these different problems. So hope you guys have a good day.